emotional issue. I'm not going to put my data there because they can't take care of it as good as I can, right? So the way we deal with that is by ensuring we have transparency and visibility to process, and while the moving parts may be abstracted, we're really, really interested in what that means in terms of how I can take, from a compliance perspective, my existing operational models, my existing controls, and either compromise by making risk decisions, or be able to deploy new technology that takes care of some of these things for me but allows somebody else to do it. So this notion of stacked turtles, and this is a follow-on to my presentation that was that had frogs as a theme, so I used the graphics instead of turtles. But has everybody heard of the stacked turtles analogy? Turtles all the way down, like a game of Jenga, right? You pull one stick, they all fall. One turtle at the bottom falls, they all fall. So the notion here is that when we look at cloud and we look at what it means, cloud is not a technology. My coworker James Urquhart says, and very wisely so, said that cloud is an operational model, not a technology. So we really have to understand what it means from the perspective of how operations change. So when it comes to cloud, we are really talking about stacking clouds on clouds on clouds on clouds, multiple dimensions of things, staggering amounts of interdependencies and complexity obfuscated by a nice tidy bundle in a web browser. And that's problematic because we are building on what amounts to a very, very shaky foundation. We take it for granted. We all nod. We all know that the internet is, pretty much unstable in many cases, and there's a lot of handshake deals that go on as it relates to how our data gets from point A to point B, but we accept it. It's reasonably resilient, but the reality is we are talking about now wholesalely moving data and applications potentially outside of my control and outside of my ability to affect compliance, security, and do what I do today. And it's based on stuff that is, and a set of problems that we're going to discuss today, both directly and in analog, that should make you a little concerned. So there's an airline in India, and there's called Air Deccan, and I found this rather interesting because there's an ancient Hindi myth that says just because you can does not mean that you should fix an Airbus A320 that flies at 36,000 feet with a piece of duct tape. This picture was unfortunately taken by a gentleman waiting to take off out of the cabin window. So I found it a profoundly interesting analogy that, from the perspective of cloud, we have this fantastic capability and we're pretty much patching holes with duct tape. So when we think of this in a more relevant analogy that we get to participate in every day rather than sitting there watching somebody repair your plane with duct tape, I thought about, hey, when we drive down the street, the only thing that essentially prevents somebody else coming at 80 miles an hour and hitting me head on is the fact that he or she wants to get to their location as badly as I do, and those really, really secure yellow lines painted in the middle of the street. When something like this happens, we react one of two ways. We sweep up the mess, or we put in Jersey barriers, sometimes both, and we just hope that people don't hit the Jersey barriers. The reality is it doesn't really solve the problem. So there's an awful lot of, again, reliance on the fact that we hope people do the right thing. Unfortunately, that's good for a small percentage of the audience, but the reality is that when we think about our adversaries, it doesn't really apply. And so when we look at, for example, what this means to providers of cloud and virtualization services, I love that picture. So far, we've gotten, with brand new technology, hypervisor vulnerabilities, lack of trusted computing-based implementations, a lack of standards, introduction of monocultures with brand new sets of computing resources that could be tens of thousands, if not ultimately, as Google states, up to 10 million compute nodes, information leakage, substantial downtime, and a ton of security by obscurity. Trust us, it's secure. When we look at how the security industry has responded over time, it's kind of easy to understand how that's happened. So these rings represent a continuum. The outer ring is how users have interacted with their data. Ultimately, as we move in closer, one ring lower, it's how we have typically enjoyed compute. Then there's how data has been either centralized or decentralized, and then bandwidth in terms of speed and reliability. So we started with the ever-friendly mainframe, very centralized data, centralized compute, slow for the most part. We went to minis and micros. We got the client server, a little bit more distributed, more powerful on the end node, more compute resources that were connected to the network. Web 1.0, we started much more distributed capabilities with protocols that were stateless, ultimately then getting faster, more reliable. Web 2.0, thinner clients, but really interesting models for program language program language development that allowed us to execute some stuff, like, for example, Ajax, locally, but some distributed, with data distributed and local. Very interesting model. And then virtualization kind of injected some distribution, but through consolidation at the same time. And now we're kind of at this point where we have the cloud, right? And we have these two very divergent models, neither of which we are very good at securing. And to that point, the security industry's response thus far for each one of these transitions has been this magical and impervious device called the firewall, right? And Gunnar Peterson did this great thing. He built this table that said, look at all the cool development languages we've had over time, and look at how remarkably consistent the security industry has been. And that's pretty much the extent of it, right? Variations of a theme of network firewalls and SSL. That's where we are. That's our solutions today, for the most part. And that model just doesn't ring true. It doesn't, and yet we don't push, we don't stretch, we don't essentially encourage providers to do things differently. And for cloud, we really need to. And that's kind of the premise of what we're going to talk about. Because when we look at what I call the hamster security sine wave of pain, and we look at how we've invested in security controls over time, and my apologies to Andy Jacob, he came up with the hamster sine wave of pain, we move from host security to application centricity, to information centricity, user centricity, to network centricity, each of them having their relevant time in the spotlight. And effectiveness for 5 minutes of 15 minutes of fame here. The problem is it goes on and on and on and on, because what's interesting is if you overlay this notion of disruptive innovation, which is almost, and it's kind of a smooth curve, but we're almost 180 degrees out of phase every single time with when a disruptive innovation hits. So in this case, I picked one, virtualization. So as we focused on network centricity up here, being able to apply things and correct things at the network level as we move through this evolution, all of a sudden virtualization comes along, claws the network into the host. The network doesn't look like what it used to look like. It doesn't have visibility. We can't manage it the same way. We can't secure it the same way. We are 180 degrees out of phase. We wonder why we don't time this thing right. Sometimes we hit in the middle, but then we get another big burst of disruptive innovation and the cycle starts anew. So the challenge here is for providers and the security industry to get together and understand what disruptive innovation means to the controls and the solutions they provide. And to give you another practical example, we take this virtualization and cloud theme to its natural progression. And we see this thing, what I call kind of converge simplexity, right? The most, it's an incredible amount of convenience and power when you look at how we are taking compute, network, and storage and smooshing it down and integrating it into single platforms. And so the issues we have then start to intensify, especially when you look at the fact that as the network speeds and feeds go from 1 gig to 10 gig to 40 gig to 100 gig, and you see folks essentially flattening out and going back to really, really flat layer 2 networks, giant broadcast domains to enable things like virtualization and vMotion capabilities, and the need for terabit switching fabrics at layer 2. How the heck are we supposed to take solutions today that barely run at speeds that function, to protect a small amount of hosts, run at wire rate while applying security in balancing connectivity? And so the reality is this is really a squeezing the balloon problem, right? We're constantly playing catch up on that hamster sine wave of pain. There are some folks that when you get into arguments, look at and make a very good claim that the internet as it is today, and we're talking about the internet because I'm really focused on public clouds, is just fine, right? There's nothing wrong with it. It will heal. It has made incremental progress. But the amount and the rate, the velocity of disruptive innovation is starting to really show its age as it relates to what the internet's able to deliver. No pun intended, Vint, sorry. So I like to take this problem of security and the cloud and chop it up into 3 buckets, because if I throw all the stuff I just threw at you in one bucket, you probably want to just start drinking, or you're just going to give it up because you just start chasing your tail. So I like to separate problem sets out into graphical form. So I built this visual, and I separate things into 3 layers. Infrastructure, another one called infostructure, another one called metastructure. And the definitions are pretty simple. Essentially, infrastructure are compute, network, and storage, the cogs and moving bits. At the top, at the crest, you have content and context, apps, data, metadata, service delivery functions. And in the middle, we have the glue and guts, the protocols that deliver these things. Now, prior to virtualization, metastructure like BGP, IP address management, identity management, when we didn't have mobility, glued those 2 things together. They were, static affinity between infrastructure and infrastructure. So we didn't have to think about how things moved around too much, because they were pretty much, you plug it in and that was it. But now that we have mobility, we have virtualization, the actual pods and contents can move, that middle layer is really, really screwed up and showing its age, right? And each one of them have problems of their own, but when you group them together and you start thinking about interdependencies, turtle, turtle, turtle. And we're going to get into each of those with some examples. So when we talk about owning the cloud, we're going to separate them into these boxes. Prior to do that, I have a public service announcement that suggests I'm supposed to tell you that the cloud